What's up, everybody? Welcome back. Today we are working on building an animation system for our collaborative Rube Goldberg machine. So, context for the project. We are working on this Rube Goldberg machine. Rube Goldberg machine, just a funny way of saying machine that does nothing of value, right? But it's fun to look at. And so we have an example up here where we have 1, 2, 3, 4, 5, 6 chambers, where each chamber is defined by a WebAssembly module, right? So the global simulation knows that it has like balls, and it knows that it wants to like apply velocity to these balls every frame. But what it doesn't know is what is actually happening within the simulation, right? So the fact that you see these platforms bouncing around back here means that like some WebAssembly module is deciding to render those platforms, and it's also deciding that when a ball hits the platform, that it wants to apply some sort of physics impulse to the ball, so that next time when the global simulation steps, he goes, "Oh, the velocity of this ball changed. I'll send it up instead of down." Right? Essentially, that's it. And so the idea is that these like chambers should be able to have pretty unbounded like complexity, right? They should be able to like render whatever they want. And so you can imagine that like you can have something like, I don't know, like a chamber that has like a portal and the ball goes into the portal and it flies out, or like one where you have no gravity and you want to like orbit some planet, or one where you're trying to play Pong, right? And these paddles will try to like catch the balls. Maybe you have like a breakout like game. It's very similar in the similar vein, right? With like some AI controlling paddle. And so what I want to look at today is like a lot of the ideas of what these things could be, right? Imagine where like maybe you have like some stickman and he's like he runs around to all of the paddles and like tries to hit them with a golf club, right? Something like that requires like a reasonable amount of complexity that we don't support right now. Not support, like it could be done, but I haven't done it yet. And so there's a lot of questions like, if we try to make something that's like real and complex, what kind of like size or in computation bounds are we going to see on this thing, right? Are they going to become really big? Are they going to become unmanageable? Are they going to become like expensive to compute to the point where our simulation doesn't run? All of that stuff needs to be sorted out. And so we're kind of in the stage now where I want to start building chambers, real chambers, and see what they look like. And so today I want to see if we can do any sort of animation, right? So I'm imagining, right, you have like some stickman, he walks around and he just runs. And let's just kind of see, maybe he'll like try to kick a ball, and when he kicks the ball, it'll go flying or something. But I want to see how we would build something like that. And so the plan is make an animation, render the animation, apply physics to the animation, and try to make something interesting out of it. That's kind of the overall plan, and we'll just kind of see how far we get. We'll see how far we get. And so I'm thinking like to make the animation. Well, okay, let's start with what do we have the ability to do right now? Pretty much everything that we can do in a WebAssembly module with code that we've already written is shown right here, right? We can draw we can draw circles. We can draw a line at any angle, which actually was like a surprising amount of work. We can draw things that move. We have implemented this like 7-segment display, which is just made out of a few lines. But we don't really have a lot, right? And so I'm thinking that with what we have right now, we should be able to draw a stickman out of some bones in an animation, right? So I'm thinking that what I want to do is I want to get into Blender, and I want to try to like animate some guy. And what we can do is we can just take the bones that we see in Blender and use those as like the arms and legs of our stickman, right? That's kind of what I'm thinking. That's what I'm thinking, but we'll see how successful that is. And then I'm kind of thinking that because Blender is like super scriptable, I don't know, there might be better software for this, by the way. I don't know what the fuck I'm doing. But I think that because Blender is scriptable, we can just kind of like make an animation in Blender and then export it with a Python API. We can like generate some Zig code from Blender's Python scripting engine, and then we can use that generated code in order to do the real animation in our module. That's the plan. I think if I go from the top, we have X and Y, which match the axes of our world. And I think that what we can do here is we can kind of define a plane that kind of sets the coordinate system that we want. Will the animation live in the backend of the WebAssembly module? As in the WebAssembly module, right? We don't want any, like, the backend should know very, very little about everything. It's kind of like the plan. The WebAssembly modules do everything of interesting. Okay, so this is this should be at 1, this should be at 0. So this plane is a 1x1 grid in meters, but we kind of say that meters are just like our unit. And then the height of our chamber is 0.7, not 1. So this is kind of like our playing area. And I did cheat a little bit yesterday, and I was playing around. This is the first time I've ever looked at this like grease pencil thing. So I did like kind of try this thing, but I think that what you can do is you can go to draw mode here, and we can just start like painting on this thing. Let's kind of like up the strength here. There we go. So let's imagine that we have like the ground, right? And let's just make a guy walk on the ground. Simple, simple. And so I think, what does like a stickman walking look like? Walk, don't run, stickman sign. Here we go. So he's got like a kink in his leg here and here. So it looks kind of like he's got like a body, and then he's got like one arm that's kind of like this, and one that's kind of like his arms come out of his like shoulders. It's kind of like this. Now this isn't what the lines are going to look like in the real thing, but I just want like something that looks approximately reasonable as like a starting point, so that our like animation doesn't look like shit. So this kind of comes like down, and then like this. I kind of want it to be closer to the ground. We'll fix this in a second. And then this comes like down and like this. Yeah, and then let's kind of like line this up a little bit. Yeah, and then he's got his head detached from his body. Kind of like that. Okay, so let's get into this thing. We can kind of like just take this and move him down a little bit. Perfect. Okay, let's kind of just stick him on the ground, and let's animate him. Let's animate him. So let's rig him. Oops. Let's get out of object mode, and we can just kind of create a armature, which is pointing in the wrong fucking way. So I guess this guy, just kind of edit mode, move this down. Where does he want to be? He wants to be like Z0. There we go. Yeah. Probably rotation. We don't want any rotation on this guy too. Oops. Length we probably want to exist. Hello. Oh, here. There we go. There we go. Now it matches our coordinate system. So it kind of. Okay. So this is his body. And I think that remember that this isn't actually, we're not going to use the like painted thing here. We're going to use the bones as our actual guy. But it will be easier, I think, to animate him if we see a stickman drawn in real. I shouldn't say real life. This isn't real life, but okay. And then we probably want like a bone for his head. Let's attach. How do I like make an unattached bone? Can I do that? Like add bone. Call this head. Where does it go? Oh, here. So here we want like x1, z0, and then can we like this guy goes here, and then can I like parent him to this? Parent, keep offset. There we go. So now if I move this around, oh no, probably I have to go into pose mode to do that. Okay, let's save this because certainly this is I'm going to fuck up because I don't actually know how to do art in any way, shape, or form. So excuse me while I blunder around. So I think you parent this with automatic weights, and then we can look at kind of how the bones are attached to our drawing. So I think it's in here somewhere. No, this one. Grease pencil. Vertex groups. This is it. Okay. Hell yeah, baby. Hell yeah. Let's get in there. So I think if we go to weight paint, we can just kind of like look at like which kind of areas each bone affects. So this one we probably want to only affect like up to here, and we probably don't want them affecting this stuff or these. This one probably fine. There we go. Nice. This guy, get the fuck off the thigh and only connect to the knee. This guy, get the fuck off my chest. Get the fuck off the thigh. Get the fuck off the whatever the fuck that thing's called, shin. Chillin'. Did I get all of them? Oh, I started at head. Okay, so this should only affect those. this should not affect this or this, but the rest is okay. This should not affect any of these. None of this stuff. None of that. Okay. And then this, oopsies, should not affect the arms. These should only affect the torso. And not the legs either. Only torso, please. Please, sir, only torso. Okay. So hopefully now, oh, or head. Don't fucking affect the head either. Hopefully now if we go into like pose mode of the armature, I hope that we did this right. So like, yeah, that looks promising. Promising. Have I used Blender before? I've used Blender a lot, but not for like what you would expect, right? Like I'm not like a game dev or anything, but I have used Blender for like, we'll call it like, yeah, I have to be careful about what I say. I don't know if I'm allowed to talk about what I used it for, but we'll say that I've done a lot of Blender scripting. A lot of automation around Blender, but I can't really talk about why, I don't think. Maybe I can, but I don't want to risk it. Don't want to risk it. So like things like rigging and stuff is not where I've done a lot. I've done like a little bit of sculpting, not a lot of sculpting. A lot more like import 3D model and make it look realistic, essentially, right? So, and in an automated manner. So a lot of like scripting to try to figure out like how do I make a material that's ray traced of this thing look like the real thing, with little human intervention. That's kind of more. So I'm like familiar with like, you know, the interface and stuff. A little less familiar with like character design. Okay, let's try to make a walking animation. I think that it's like there's like a dope sheet, and I think in pose mode, I think that I can like press I to be like, please remember where I am right now. And then I think here we can look at like this stuff. Okay, so let's just make like a 30 frame walking animation. So we'll kind of assume that we want the animation to loop. So we'll kind of like duplicate this to 30 frames. And then we can kind of just start bisecting. So we know that if we're doing a 30 frame cycle at frame 16, 15, 16, he should be halfway. How do I want to do this? How do I want to do this? I guess maybe we'll start by moving him like for real so that we can kind of get the feel of like what walking should feel like. And then we can come back. And then we can like kind of like keep his position centered after. I like that. I like that. So I guess at this point, we are going to basically have moved our guy such that his foot here stays in the exact same spot, but he's moved one step over. So we can kind of be like, fuck. So I guess he's gonna kind of like be back here. It looks like we drew his left leg shorter. So we can kind of like just match this approximately. It doesn't have to be perfect. Fuck, he got the ground in there. Okay, can we go to weight paint mode? Weight paint mode. Let's get out of object mode. We want object mode, then we want to click on the pencil, and we want to go weight paint. I want to figure out which of these fucking bones is touching the fucking floor. Get the fuck off the ground, please. There we go. Okay. What were we doing? We were in pose mode trying to figure out our animation. So we switched the legs. I guess we just keyframe this and like, so in this one, the right leg is supposed to be longer and kind of like kinked down more, like this. Right, is that kind of what it looked like over here? It was maybe even longer. Oh fuck, wrong frame. That looks about right. And then to the back leg. this is kind of like down here-ish, and then this is kind of kinked back more and scaled up, like this, maybe? Yeah, cool. And then we want, at this point, for him to kind of be like over here, so that his leg doesn't move, right? When you walk forward, your foot stays on the ground. That feels about right. And then here, we can just kind of adjust so that his feet don't go through the fucking floor. So maybe we keyframe here, and we just kind of... so we need to make sure that the right leg stays in the exact same spot. So here, it should kind of be like rotated up and rotated back. And then, I forget, is the thigh shrinking or growing? I don't remember. Shrinking. So we could even like shrink this a little bit if we wanted to. That right leg feels pretty good. Left leg just has to go up a little bit. So here we need to make sure that like, maybe when you walk, I think that your like knee does a lot of the lifting, maybe? I don't fucking know. That feels pretty good. Oh yeah, baby. Look at that walking animation. Look at that. We're like fucking real talented developers. Okay, so here we need to make sure that his back foot here needs to end up around here. So can we just like, what? Oh, it actually needs to go even farther, like here. Here to there. Well, I never realized simple rigging animation is this easy. Yeah, it's pretty sick, huh? What like a fucking... This is like, I think, probably my favorite piece of software ever. Like, it's so good. It's incredible. It's like, it does everything too, right? Like, right now we're like rigging and doing animation. This is like fucking like photorealistic renders. It's such a good fucking piece of software, man. It's so sick. Okay, so here our leg is moving, so maybe we keyframe like here and just kind of move him back. So this should be like, maybe like this. I don't know. Maybe still a little more to the right. Kind of like pick this up a little bit. Okay. That felt pretty good. That feels good in terms of like his forward leg, his pushing leg. It goes into the ground a little bit, but I don't really give a shit. And we just have to kind of make sure that the back leg is also kind of doing the same thing. So what did we say? We said we were kind of doing something like this. Probably is fine. Boom. Boom. Yeah, that feels good. So now if we like, we need to then make sure that he stays kind of in the same spot. What is this all about? Missed the intro. Basically, the idea is that like if we wanted to make a complex chamber, like I had like a bunch of ideas for chambers of like, you know, there's a guy here and he's got like a baseball bat and like a ball flies in and he like swings the baseball bat and hits the ball. Something like that requires some form of like animation system, and I want to understand like kind of if we were to start working on these like more complex chambers, what is like the like, you know, what can we expect in terms of like computation and like size, right? How much data do we need in order to like do animation, stuff like that? So I want to render something in a chamber and just kind of see what happens, right? Just want to see what happens. Okay, so now we just have to make sure that like we put him back in the same location. So here, can we like look at this bone position? Does this bone move over time? It does. So we can just kind of go back here and we can just set this to 0, 0, and probably, fuck. Fuck it. We'll just like kind of eyeball it. Oh, so here we also have to move him back a little bit. So 0, 0, and then maybe these guys can also go back to 0, 0 actually. Oh, they can. Sick. Keyframe everything. Then here, we also want these three to be set to 0, 0. Fuck. Nope. This one to be 0, 0. This to be 0, 0. This to be 0, 0. Okay. Chillin'. And then the same dealio here. Where I guess at the end frame, we just want the end frame to be exactly the same as the start frame. So we can kind of do like... how do we do this? We kind of like select everything in this frame, duplicate it, and bring it up to the last frame. Boom. Okay. And then what do we look like? Okay. Legs are good to go. So yeah, learn that your legs shorten while walking. Yeah, we can cheat when we're animating, which is kind of fun. On the second step, he kind of like picks his leg up a little more, but I think it's kind of fun to have some sort of asymmetry. Okay, let's swing his arms. Let's swing his arms. So all we have to do is swap them. So we keyframe these and these. And then... Oh, Jesus Christ! Oh, because they're not keyframed here. So can we just unkeyframe the arms? We can just kind of... Can we just delete, like, these? Let's save because I'm not really positive about this. Yeah, it feels like it works. Feels like it works. Yeah, that feels good, huh? So if we, like, delete the armature now, and then set the fucking walk cycle to 30. Hit play. Oh, look at that. We're fucking animators. Look at that. That's a guy walking, if I've ever seen one. Wow. We're so cool. Look at that. Okay. So I guess we now, like, before we render the animation, we have to figure out how to, like, export it. Why is the head floating? Because it was floating here. In the do not run safety sign. Should his head bob or something? No, it's not worth it. It's not worth it. I actually kind of like the way the leg comes up in the second one. I almost want to do that. It doesn't matter. It really, like, who fucking cares? Who fucking cares? That's not the point of this. Okay. Scripting. So can we just like import Blender scripting interface? His mouth should open and close as he walks. We like Pac-Man. He could eat the balls and teleport them into like his asshole, and he could shit him out as he goes by. Never mind. Never mind. Is this your first time using Blender? No. I've even like I've rigged stuff before too because as part of like if I wanted to generate something that would have like some sort of like random form. Why would you say it like that? I said never mind. Okay. I think there's like this like objects thing, so we can look at the armature, I think. This is hard because I don't have like a way to print right now, huh? But if I introduce like a compile error here, it does fail. Okay, so we have like something. And I guess we just need to look at like the Blender docs. Blender docs. No, I don't want Blender docs. I want BPy docs. So Blender has this like super powerful scripting engine where basically like everything that you can do in like the whole thing is like exposed through this module. Now the way that it's exposed might be kind of shit, right? Because it's more like imagine you wrote a program and you wanted to script it. You might make a scripting API which has terrible documentation, right? But it does everything you need it to do, right? So you can kind of think of it that way, right? It's kind of like for them, but works for us, if that makes sense. So in here, I think that I want to look at like, it's been a while since I've looked at this, to be honest. Armature is probably, can we, BPy ops, BPy types, armature, this is probably what I want. We probably want like the bones. And I remember You know what? Here's what we're gonna save this. We're gonna save this, and we're gonna open this in the command line. Because if we open in the command line, what do we call this? We call this like dude.blend. We should be able to get prints, and those prints will be like incredibly valuable. Yeah, okay, here. So we have an armature object, nice. And in here we can look at the bones. So let's look at the 4 bpy data objects. I guess we'll call this arm. And then we will say we have bones. So 4 bone in arm bones. Is it a property or a what? Yeah, okay. Print bone. Let's just see what we get. Fuck. No, object has no attribute bones. But it said it was an arm. bpy types armature. Are we fucking high? I thought it was. Also, I guess we should double check what Blender version we're using. That's probably really important. No about? Is it here? There. 4.1. So these docs are for current. Close enough. Let's print arm again. It does think it's an object armature. Oh, maybe this is. Do I need to look at like his object is generic maybe, and I need to look at arm data? There we go. There we go. Yeah. So the object is like this like generic class, and inside he has a data pointer, which is like the particular. So we have all our bones, which is cool. Can we look for bone? What isn't a bone? Right, because like surely we have like a start and an end of a bone, and I'm hoping that we can get like the start and the end of the bone like at each frame. That's what I'm hoping. But we'll find out. Probably this. So we have, I think probably head seems promising. Location of the head relative to its parent. Can we get like head world? We'll probably have to apply some like backwards transformations. That's fine. We'll live. Is there no easy export format already built in? What fun is that? But you're right. I didn't even consider that, which is pretty funny. Blender export animation. That's really funny. I like literally didn't consider that at all. I guess probably we can do like something like file export. What's in here? So these are like model. Motion capture? Probably. I doubt this is what I want though, right? Like, because the thing is, no matter what we export, we're going to have to import it. We're still gonna have to write some code to parse whatever format and generate whatever we want in our thing. So I think it's probably not too bad for us to just work in Blender space, because like we're gonna have to learn something, and so we might as well just go directly from Blender to Zig. But maybe that's stupid. But oh well. Okay, what else is, so we have bone. I was hoping for some JSON or something. Oh yeah, I doubt it. Tail and head. So let's print the bone head here and just kind of see what we have. Okay, so these are 3D points, which are very good. Zeros is or the Z component is 0, which is also very good. Very much what we expect. And if we have the head and the tail, it looks like we do see some sort of like y-axis movement for this guy. So it looks like we have something. Now, what I want to know is if I move from one frame to another, are these different? So I hit play again. It looks like no. So it probably, what we're iterating right now is like the actual definition of the armature. And somewhere there must be the definition of like what the armature's state is right now. That must be somewhere. And so can we look at like, I wonder, this kind of seems like something that ChatGPT might actually be good at. To be honest, I'm working with Blender's bpy API, and I'm trying to get the position of bones in an armature at every frame. Do you have some suggestions? Can you give me some sample code. Dude, this is pretty crazy. I know I shit on ChatGPT all the time, but this is fucked. Like, that's actually so crazy. Context scene frame set. I feel like, so he's looking at, oh, armature pose. So here's the pose in here. So we're looking at the bones. He's looking at the pose. So if I go in here and instead of looking at bpy arm data bones, he's saying that we have like arm dot pose in here, which gives us a pose object. And if we look at, can we iterate over the pose bones instead? Okay. So now let's try just moving between frames and seeing if those get modified. Yeah. Look at that. So this now is different numbers. Hell yeah. Okay. So we have basically all we need here, right? This is just at each frame, the position of all the bones. Now, we could log the position at every frame for all bones, but in reality, that's not really what we want. We kind of just want keyframes, right? Because we can interpolate between the keyframes ourselves, and that will save us some data. But I think before we do that, let's not export the full animation. Let's just export one frame and see if we can render that frame. Because I think that like kind of looking at the problem holistically will result in us doing something more reasonable, right? Trying to get everything right here first is fucking stupid. So maybe we'll say, well, this section is export a frame. And we actually forgot to say what time we started at, but we know it's sometime before now. And we'll say that the next step is to render a frame. Okay. So how do we want to export this thing? You can probably access the keyframe positions directly from the animation. Almost certainly. Yeah, I agree. But for now, let's start by trying to generate some Zig code. So you can do something like const bones. Bone. We're gonna want a struct with a X position and a Y position. Yeah. And then what are we gonna do? We're gonna want to say like const bones is a list of bone. I swear that was a typo, and I swear it's not like muscle memory. I don't know when the last time I typed boner into my keyboard was, but I fucking swear to God, guys, I swear it's not what you. It's not like a Freudian slip. Freud's an idiot, right? We all know that. Okay, it was. Me defending it is not because it's true. It's because I'm trying to get ahead of it. Okay, you got. So this is lowercase bones, and he's gonna be like. He's gonna be like this and getting a little defensive. Shut the fuck up. So here, I guess for each bone, we're going to add one of these blocks. So this kind of gets ended here. This has to say const. Oh, it did. I just can't fucking read. Can I not increase the size of this thing? Oh, I can. Scroll. Hell yeah. Hell yeah. Okay. So now I should be able to be like, for bone in bones, we append just something that looks kind of like this, and it's like dot x is equal to x, bone x, probably. Something like that. And then at the end of this, we just print out the end of this structure. So it's like this? Maybe. Fuck. Unterminated string literal. Can I do multi-line strings? Do I have to do like this? Is that how this fucking works? Oh no, it's a triple quote, right? Triple quote lets me. Fuck, I press insert, the worst key of all time. Yeah, much better. And this is printing something that almost looks right, except that I didn't actually fill anything here because I actually print this string. I can't just type the string. Dude, what a funny language. They're like, the convention for doing doc strings is to just write a string and just like discard it. What a funny language. Okay, fuck off. This needs to be an F string. Can I do like an F multi-line string? Is that legal? Negative size passed to pi Unicode. Okay, fine. We'll say x is equal to bone x, y equals bone y. Let's just make sure that those are valid, and then here can we pass in x and y like this? Is that kind of more sane? Negative size passed to pi Unicode new. Can we like maybe like right x y here? What the fuck are these things? Fuck. Yeah. I hate not having Vim. I hate it. I hate it. Pose bone has no attribute X. Bone 0 maybe? Bone 1? Fuck. Only strings. Head tail? I was supposed to do head and tail, huh? Yeah, it's a really good eye. Thank you. Which means that our structure here, I wonder if this should just be surface. No, fuck it, whatever. We'll make it anything. So we'll call this A pause 2, B pause 2. Which means that this is gonna have to like import physics. Like this. And then this is gonna be const pause 2 is equal to physics pause 2. Guys, this is how you write code, right? Just a string inside another, like a string in a script inside Blender. This is how you code. Okay, so cool. So we're here. Each thing is going to be. This is peak performance. Yeah, perfect. This is what Turing always envisioned. Yeah. So here, can I do like, am I allowed to type bonehead X? Is that allowed? No. Head X is equal to bonehead. Oh, 0, right? So this should be head X. No? Bone. Oh, I need to print head X. Oh, maybe I have to cast this so that it gets out of like BPy types. It's probably like some like Blender type that happens to print a lot like a float, but isn't exactly a float. So here now probably I can type head X and that will probably work. No, negative size still passed to pi Unicode new. What the fuck? What does that mean? Because this is clearly like valid. So maybe we're just not allowed to do float F strings here. Let's try this. Let's try that. Unexpected. Oh. Maybe I gotta do one of these. Is it double in this language to escape them? Ah, there we go. And then here we can probably go back to using this. That's probably fair. Yeah, that works. Okay. Okay, so we have bonehead 0, bonehead 1. I'm a bonehead. And then we have the same thing, but with tail. God damn, dude. I wish I had Vim. And then this is going to be like dot A is equal to this. No. A is equal to this. Yep. Dot X is equal to this. Dot Y is equal to this. This needs double of these braces so that the format string doesn't like try to use them. And then this is B. is equal to dot this. Yeah. Okay. That looks like it might compile. Might. It's kind of, fuck, did I forget to copy? I might have pressed it at the wrong time. There we go. So let's save this because we're gonna need that later. And let's try to make a WASM module that has that fucking bone structure in it. Chambers, and we're gonna call this like dude WASM, dude zig. Okay. I guess we're gonna make it source chambers. Well, I guess we make dir source chambers dude. Then we edit source chambers dude bone animation. Sig? Fine. Seems fine. Pretty sure you can write simple expressions in format expression like bonehead 0. Okay, good to know. Okay, so now we go into dude zig, and I guess we just kind of like copy another chamber that we already have, like simple zig, and then we say const animation is equal to import dude animation zig or something. Okay. We need to add this dude thing to our build script. Build chamber. This is gonna be dude. Okay. Let's see. Okay. Good sign. Let's introduce a compile error just to make sure that we are building what I think we're building. We are. Chillin'. Okay. And now let's try to kind of see if we can render our guy. Okay. So this is, we can kind of yoink our render line function from the other one. Where was it? It was spinny bar was where we were rendering a line before. Let's just kind of like yoink out our render line section. Kind of slap this down here. We need const pause 2 is equal to physics pause 2. Okay. We need the 2x and 2y pixel functions. So this is in spinny. I know. We are going to factor this out eventually, but I want to see kind of what this API, like what is common. I want to understand what's common first before trying to split it out. But we will split it out eventually. Okay, and we should just be able to like iterate over the bones and draw the guy. Maybe. If we did it right. So if we do like this is animation. Bones. So if we look at each bone, I fucked up a capital P in the Blender script part. Okay, good to know. Thank you. It will probably break here in a second, but we can check. Unused capture. So here is bone, and then here we kind of say canvas width and canvas height. Bones is not marked pub, so let's go back here and just kind of pub. You're right. This is supposed to be capital P. You are correct. And I guess we just have to copy paste this again, which kind of blows, but it's a problem for future me. Okay, let's try that. That builds, shockingly. Shockingly, that builds. And so we should be able to just say, like, for each one of these things, we get to render a line. So let's just bone A, bone B, chamber width, chamber height, and canvas. I guess. Can you write to a file from Blender? Definitely. Definitely I can. I just haven't. Oh, it's canvas width and canvas height. I do this every time. Get the two mixed up. And what is our, we call it chamber pixels. Okay. This should be canvas height. Okay. Dude. Does this work? There's no fucking way, right? There's absolutely no way. What is it called? Dude? Holy shit! Wait! That's our guy! That's not that bad! That's not that bad. I mean, it looks fucking stupid, of course. But that's a really good sign. That's a really good sign. So we also forgot to say that we started rendering a frame, but this is sometime before now. Okay, let's try to export like keyframes. It's the guy. Yeah. Okay. Okay. The dude is being destroyed by balls. Yeah, he sure is. Okay, so how we need to figure out how to get like keyframes out of this thing. So probably it's going to be it's probably not attached to either anything that we have in here so far, actually. Right? It's probably not attached to the armature or the pose necessarily. It's probably external somewhere. So maybe we can look at like a let's go back to ChatGPT. That guy's really good at searching API docs fast. How can I find the keyframes in a animation? Question mark. Accessing F curves, identifying keyframes. Oh, I didn't name cube. So here he looks at action, animation data. Ah, okay, this is promising. Move to a shittier country. I get no ads. It's perfect. Okay. So, interpolating the F by inspecting the F curves associated with the animated properties. Do I need to use F curves? Is there an API that just gives me like keyframe positions and timestamps? Question mark. So he's claiming. Oh, that looks really promising. So he's saying that if I just look. So if obj animation data for curve and for each keyframe point for each object. So I want to like walk the bones, grab the animation points for each bone. Well, let's also double check that. I know I was like pretty liberal with my keyframing. I would be kind of curious to see if they are kind of, how do I say this? I want to know if the keyframes are for everything. It looks like, so here we keyframe every single thing. And here we keyframed, I think that we should probably name our bones, huh? That would make this a lot easier to inspect. Like a lot easier to understand. So we can go under here, and can we just like, this is head. Like, how do I know which bone is which? This has got to be one of the arms, right? If I click on the bones in here, does it select them? Ah, it does. Sick. So this is a forearm. I'll call them forearm 1 and forearm 2 because I don't know which one is which. Bicep 1. This is bicep 2. Forearm 2. Yeah, sorry, two-step. I ignored your question until you got back. Looks like add is done. So, are you running from Zig? Yes. We basically just iterated the bones and drew lines. We already had line drawing codes. We just copy pasted it, and it's just like walk the bones, draw the lines, which is pretty straightforward. It just happened to work, which is pretty nice. Thigh 1, shin 1, thigh 2, and shin 2. Okay. Okay, that updates the dope sheet, which is sick. And now we can kind of see, okay, so from here to here, we expect both legs to have animation attached to them. What is bone? Oh, this is like the body. Yeah, so that kind of makes sense. We only have no keyframes to the arms, so the arms only are keyframed at the center. Yeah, okay, so that's pretty reasonable. Pretty reasonable. Okay, so I guess we just kind of do whatever ChatGPT said. We iterate the F curves for each object. So what does our like API look like here now? So we have bones, and I guess for each bone, we are going to have animation data associated with it. Right? We almost want to we almost want to animate each bone independently, right? Because then we can just store kind of like the keyframes for each bone. This, I guess, though, this position, like the head and tail of the bone, is going to change every keyframe. So it's almost like we want like a keyframe. And what's the keyframe going to have attached to it? What's the keyframe going to have attached to it? Like a timestamp? As well as a position, a bone. No. Yes. We can call this like a, sure. So then over time, we're going to have like animation data for a specific object, which is going to have many keyframes, where it's going to interpolate between the bones given the time steps. I think that makes sense. Sure. So then we can have like const animation is just going to be like a list of keyframes. Yeah. And I guess we're going to have kind of like for each object, we are going to have an animation associated with it. That makes sense to me. So we'll call this like objects. And this is going to be a bunch of animations. Yeah. Yeah. This is sick, makes me want to learn Blender. Yeah, I think I'll say it again. Blender is my favorite piece of software. It's very, very good. It's very good. I mean, of course, you need to have a use for it, but it's like a testament to what open source can do if it's done well. I think that yeah, it's very, very sick. Okay, so he's kind of saying that I want to iterate over so we're going to look over all of our. So he gets the object, then he pulls out the animation data for the object. So I guess our animation data is going to be it's like for a bone. But like the animation data, if I remember correctly, the Blender data model. So I'm kind of working off like previous understanding here. The data model is like you have like object, and then you have data. And generally, the object is like an instantiation of the data. So you can imagine that like data, you're gonna have like, you know, your like mesh, right? So you're gonna have like some sort of like your cube, maybe, right? The data is kind of like these are the vertices of my cube, and this is constant, but you can like have many instantiations of this data at different positions, right? So this object is going to be like I am cube, but I am at cube position 100, and there's another object can be at like cube position 200. And so when I'm looking at this API and I'm looking at like this animation data, it looks like it's attached to an object, right? So I don't know which object it would be. Probably the armature object. So that's this. So maybe we can like maybe try like print arm animation data. And then can we like return from this, or is that legal? Oops. I think this is what we looked at before. Return outside function. Okay. Can we just do? Can we do like def main here so that we have a function to work in? Then here we can return early, and then here we can call main. Okay. So do we have some animation data? We do have animation data. Okay, we can just kind of start looking at what ChatGPT is saying is in there. You know, he's a liar, but maybe he's not this time. How to learn to code. Every time I try to find it so hard to grasp and understand anything, when I try to code on my own without videos, is a struggle. I need some help, please. I think that, like, unfortunately, like, the struggle is the learning. I don't have, like, really... I mean, it's hard for me to answer this because I started coding, like, 15 years ago, probably longer. I don't know, like a long time ago. And my recollection is that I just had problems I wanted to solve, like small things, and I just had to like fucking plow through until I figured it out. Now I know that's not how everyone learns, right? Some people learn through classes, some people learn through tutorials, some people learn through whatever. But like I'm very fueled by just like I'll figure it out eventually, and I just want to like I need to work on something, right? So when you're saying like, you know, it's a struggle, I'm not understanding, I'm like I need some help. It's like I the struggle is like the learning process, right? You go like I have this problem, I don't fucking get it, I need to understand it, and then you just like keep slamming your head into the fucking brick wall until you fucking finally bust a hole through it. And like there are efficient, you can like gain efficiency, right? Like learning is like a skill in and of itself. I like get that. But unfortunately, I don't have like how do I learn? It's like I don't know, man. Try. Like it's like unfortunately I don't think there's like a shortcut or like a better answer than just like figure it out. Like, I don't know. Unfortunately, but like again, like I guess I should say I guess that's not true. That's not true. You need to understand like what resources are good for you, and try to seek those out as well, right? Like I think back one of like my favorite. I took piano as a kid, and I don't know how to fucking play the piano at all right now, right? Like at all. But I think about like the way that they made us practice all the fucking time. Like the idea of that like just time is not sufficient, but time and focus and focusing on the right things is like an incredibly valuable learning tool, I feel like. So like the idea that like you need to understand like you know, if you're like I don't know how to do this, and then you type it into ChatGPT or you watch a video that's like how do I do this exact thing, and you just like watch the video and copy paste it, that's not like effective learning, right? Like the effective thing to do is you have to like understand, well, at least for me, is that like I read, watch, whatever, and then you have to take that extra step of being like, okay, so what the fuck did that do? And like I find that like mutation testing, like just like look at what they did and then change it in some way and see if like your expectations match the behavior is like very valuable. But again, like this is kind of like it's hard to say what like a brand new programmer should do. I don't really fucking know. Books are created for the courses, at least for me. Yeah, I've read like basically no books ever, but people who love books love books. I get it, and people who love courses love courses. Okay, so we have some animation data. Let's try to like inspect it. So this guy, ChatGPT, he's claiming that the animation data is going to have an action associated with it. So let's kind of like, what the fuck is an action? What the fuck is an action? That doesn't crash, which is good for us. He has an armature action, which is sick. And he's saying that he has a bunch of curves associated with the action. So can we look at like, for action or for curve in animation f curves? Let's like print curve. What the fuck is in here? Fuck. F curves. We'll get there. Okay. So this has a bunch of f curves, and it would be kind of nice to count them, maybe. So here we can say like print I and curve. Like let's see like how many of these are there. How many of them are there? So we're getting like 99 curves, but a bitch ain't one. Which feels like a lot. That feels like more than we should have, but we could take a look again. So here we have maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And like 1, 2, 3, 4 frames. So like we should be seeing like on the order of 40. So I don't know where these 99 are coming from. Oh, but I see. The curves are different than the points. So we want to actually look at the keyframes in the curve. Okay. Let's look at the keyframes then. Which again, I feel like we're only going to get more. But I guess sometimes the keyframes, they might have 0 keyframes. So we can say for keyframe in curve dot keyframe points. I'm like shocked that ChatGPT is doing this good a job, by the way. Like, to be honest. Like, he's killing it. So here we have 400. Fuck. What are these all for? Okay, we can ask them some more. Say, okay. So if I have an armature with bones keyframed individually at certain frames, how do I inspect a keyframes for a specific bone? Okay, so he's got an armature, he's got the bone, he looks at the... oh, okay. He's claiming that the bone, it's attached to the pose, which I guess makes sense, because when we looked at the pose, we did see that the pose bone did move with the animation. So I guess that kind of makes sense. That makes sense. And here he's looking for a specific property from the animation. Oh, interesting. So maybe the animation data is kind of like global, but linked to each bone. Each bone has like a reference to some global animation data, and we have to find the curve for our specific bone. Jesus. That's pretty nasty. Okay, can we maybe like try to understand, like, if we look at the UI for animation, is there like an F-curves, a curve editor somewhere? Like, this might give us some intuition on what these things actually are. Right, so he's like, so how many curves do we think we have? Can we like print the curve here? Continue. So we have 99 curves. Does that like line up with anything in here? Like, what the fuck am I looking at? Display curves normalized for range 0 to 0, 1. Okay. Like, I feel like I see like maybe like 10 curves in here, right? Like 1, 2, 3, 4, 5, 6, 7. Oh, but they start and end. I see. Expone each. Oh, Jesus Christ. Good eye. Good eye. Yeah. Okay. I see. So when we're looking at these, ChatGPT is saying we're looking at a property for this specific bone. Oof. Okay, how do we... So I guess... Woof. Okay. So if we want like the head and the tail of a bone at each keyframe, this is the value of the property of the keyframe. Okay, can we ask him like, can I get the head and tail of the bone out of the keyframe? Because I don't really want to apply the rotation and scale and stuff manually. It would be nice if I could just like grab it. You know what we could do? You know what we could do is we could just find the keyframe points and set the timeline to that position, and then grab the head and tail out of the bone itself. Okay. Can I get a list of keyframe of all keyframe frame numbers. That's probably easier. I mean, it's not like the way that I would consider like correct, but it's correct enough. Yeah, so it's just frame CO0 according to this. Okay, yeah, let's try that. Let's try that because that feels easier to me. Did I lose Blender? It's here. So let's go back to the scripting page here, and let's just kind of say keyframes is yeah, it's fine. It's fine. This isn't ideal because now we're not going to know. Oh, I guess we can iterate per object. Get all the keyframes, jump to that location, grab it. Yeah, that'll work. So we'll just say keyframes here. We go through the animation. How do we extract? It's for keyframe in keyframe. And we just I want the keyframes for this bone. So pose bones get. So we're iterating over bones here. Okay, can I comment this out? I'll just fuck it, delete it. It's fine. So we iterate over bones, and for each bone we can look at the bone keys. Yeah. Okay. So we're gonna like say bone keyframes is this, and we are going to iterate over all curves associated with fuck me, paste. Okay. Bone animation data action curves find this. Okay. Does that give me an iterator? Yeah. Okay. Here. For keyframe and the keyframe points, we can then bone keyframes append in this language. I can't fucking remember. Keyframe co 0 is what he's saying. Then this can be like print bone keyframes. Let's just kind of see what happens. Pose bone has no attribute animation data. Fuck. Pose bone has no. Maybe it's. I'm just gonna go out on a whim here and type bone data, except that my fucking Blender is not responding. Just super cool. There we go. I'm just going on a whim here. Nope. I'm seeing that pose bone has no animation data prop. Let's see if he gives me something at all reasonable. So here, pose bone. Get this bone by name. I wonder if this just does something like stupid. No, this is what I'm doing. I'm looking over arm pose bones, which is exactly the right thing. Armature obj animation data. Oh, he's right. I see. I'm high. So we need the arm animation data. Action. F curves. Okay, these are our curves. Okay, then we are going to do this find thing on the curves. Call this F curves. Okay. Now this bone name is not defined because I just kind of copy pasted him like a fucking dumbass. Oh, interesting. So he's saying that this is data path. Okay, can we look at the, maybe we'll print out all the F curves. F for curve in F curves, print curve data path. Is that what he said it was called? Data underscore path. Should be bone.name in this context. I think so. I just want to see what I'm looking at before we kind of get too crazy. Yeah. Okay. I see. Yeah. So can we extract the data path of ourselves somehow? Do we have like bone data path? Like, is that legal? That'd be kind of cool. Nope. Okay, fine. Fuck it. We can construct it. That's fine. So here we just want this to be bone name probably. We don't care about the property because we're just kind of assuming that whatever. Then here we iterate over the keyframe points, find the keyframe, and then at the end here we should be able to print the keyframe. Maybe it's not like guaranteed. None type has no keyframe points. Okay, so here we just have to say if f curve, we do this. Okay, and then did we print out? We got no keyframes. Fuck. So we fucked it up somehow. Oh, because this is expecting a specific. Oh, okay. Find it does matches exactly. So we do want to do what he was doing. So for curve in f curve in f curves, if what do you say? Can I just like look at his data path? Okay. F curve data path starts with, yep. Is it all lowercase? Yeah. This. Then we do the rest of this shit. Okay. This and this. Play. Okay, sick. So we have bone keyframes now, which is very sick. Very sick. You could use fine with the custom plan function folder. Yeah, I think it doesn't really matter. It's fine. It doesn't really. It's cool. I'm okay with this. Okay, so we have all of the keyframes for a given bone, which is sick. Here we want this to be a set, so that we only get one per, and then I think it's insert. No? Add? There you go. Oh, hell yeah, dude. So now we are seeing, nice. So these are the arms here, framed at 1, 16, and 30. And then these are the legs framed at 1, 7, 16, 21, 30. That's sick. That's super sick. Looks like we're chilling. Okay. So now we're saying that we don't want to do whatever the fuck ChatGPT was saying we can do. Instead, we can jump to each frame. So I think that there's a way to set. Did he say give us the API there? It's like something like bpy ops set keyframe set frame set here. So let's just go to each of those frames. For frame in bone keyframes, we just fucking go. Get the fuck over there. Right? Then we extract the bone position like this again. So can we maybe start by just saying, so what is our thing again? We have our objects is an animation. Animation is a bunch of keyframes. Each keyframe has a timestamp and a bone. So we are inserting timestamp bone. So here we have .t is equal to frame. This is frame, right? And then our bone is whatever we were doing before. So A, B, all of this can kind of go in a little bit. No, all of this can go in a little bit. This closes the bone, so we have to close the other thing as well. Okay. So Yeah, maybe. This actually has to wrap one more. Right here we need to print this. Then we're gonna have a bunch of elements per bone for each bone or something. And then at the end of this loop, we print the closing brace here. Here, this gets a closing brace and a comma. And then this stuff has to be kind of in one indent level. There we go. That might work. I'd be curious to see if it works, so hit play. Fuck! Forgot a comma. Yeah, I did. You're right. Function frame expected an int type. Whoa, frame set, frame. So we'll just int cast this. That's fine. That's fine by me. I guess we can maybe cast it down here. Because it is true that frame numbers are constant. Okay, let's see what we get. So we do seem to get a bone here. So at timestamp 1, we set the bone. At timestamp 7, we set the bone again to different numbers. Very good for us. Timestamp 16, we set the bone number again. Timestamp 21, set the bone number again. And these are changing. So it's very likely that this is okay. Now, there's a good chance that I've introduced some sort of like Zig syntax error. But we can check that in a second. So let's kind of delete this. And let's actually save here. And let's see how fucked up this is. Here, okay. Enter. Animation Zig. Delete it all. Paste. And there's just a fucking stray Z sitting around. And we're missing some commas. Okay, stray Z and some commas. So this Z, get the fuck out of here. And then probably here we want a comma. Probably. And then can we change this? Instead of fucking printing, let's fucking write to a file. So, no, it's fine. We'll print. I don't want to deal with it right now. Save, play, and scroll the fuck up. I guess we can probably do something like this. Search backwards for physics, and then we can copy this, and then delete everything, paste. Okay. Redeclaration of bone, but I'm not really convinced though that's correct. We might be missing a closing bracket somewhere. It does kind of feel like that, huh? We've got an extra one here, maybe? Oh no, that feels right. Okay, let's just break after one bone, because that will simplify our life a lot. Break. Play. Okay. Physics. We want to start with selecting stuff, then we search for physics. Okay, then we delete everything and paste. Okay. So, I guess let's just start by trying to compile it and just see what happens. Animation has no bones property, so we can go back to physics. Oopsies, not physics. What was it called? Dude. So here we have animation bones, and instead now we want to look at objects, and we want to look at objects 0 bone. Or maybe we want to go for objects. Let's look at bone is equal to obj.bone. And let's see if that compiles. keyframe does not support array initialization syntax. So at keyframe, this, right, because we have an array of an array. So each of these has to have like an ampersand in front of it like this, I guess. Okay, let's try that. Expected type this, found that. So I probably need like, there's probably like a missing const somewhere. Probably here. No method named bone in keyframe. Okay, so it actually looks like it compiles. In no member named bone in dude animation keyframe. Yes, there is. It's right here. Right? Can we just like obj dot oh, because each object is an animation. I see. Oh, so that compiles. So it looks like we're probably doing the right thing. And let's kind of start now by taking away this break. We'll kind of export this whole thing again. And let's just kind of see what we get if we try to render the first frame of every bone. Oh, add const. Yeah, you're right. It was here. Was there anything else? No, I think that was it. Good eye. Good eye. Oopsies. Okay. What the fuck? I feel like I'm high. It finds a thing, it just doesn't fucking bring the cursor to it. That's annoying. Okay, let's paste this and zig build. So that builds, and I wonder what we get. So I think that we are trying to render the first frame of every bone. Which it does look like. Okay, so now let's like try to render like all the frames for each bone. That might give us a clue on if we are doing something that is at least close to correct. Where the fuck is my render function? Okay, so here we're gonna say for obj. So we'll call this like animation, and then we'll say for obj for animation obj, and then we can look at obj bone. Anim, just to dodge the fucking name collision. Oh, hell yeah. Okay, so we clearly have all of the frames in here. And now we just have to like render the animation somehow. So we should just be able to go like for each bone, basically interpolate between our like a timestamp that we're at. And yeah, we'll figure it out from there. This is pretty sick. Okay. So here we need to render the animation. So it is 1:23:55. And let's kind of see. Let's see. So, I guess we're gonna have some timestamp in our state. This can go away. That's fine. We'll leave it for now. So we're gonna have like t is an f32, and he's gonna start at 1. I think that all of our frames. I think that our animation started at frame 1 instead of frame 0. Oopies. Okay. Then what? Each step, we're gonna say self state dot t plus equals delta, and if state t is greater than third t, we just set the state back. Okay. We didn't define the state anywhere, so we can just here say that like var state is equal to state. Okay. Now we just have to fucking interpolate. We just have to interpolate. Simple. It's simple. So here we're gonna be like, get bone pause given this object, this animation, at this timestamp. Right? And then we're just going to have to make a function get bone pause that takes in where the fuck this thing is, which I think is an animation. No, we want to do this one level up. Here we go. Yes, yes, yes. Yeah, it's gonna be like this. Okay. So this is gonna be an animation, I guess. Classic. And a time step. And it's gonna return a animation bone. Okay, this comes from state t. Okay. And then I guess we just find the first thing before and the first thing after. So min equals undefined. We'll call this like before is a bone. And after is a bone. And I guess we'll make these nullable because there's a real good chance that we don't find them. These come from animation. And we'll start them as null. Okay. For item, we have if item.t is less than t, or equal to probably, before is equal to t. If item.t is greater than t, and after is equal to null, after is equal to t. This is fucking stupid. This is bone. Item bone. Here we go. Okay. Then we also have to store like the interpolation start and end. So we'll say that like var before t is equal to undefined, I guess is fine. Technically, we only need to store the like fact that it isn't set once. So this is fine. After t is equal to item t. And before t is equal to item t. Okay. So now we can say, oh fuck, animation is not marked pub, so we'll have to come back to these. But it's fine for now. It's fine for now. Okay. Now we say if, we'll call these opts, I guess. I like calling these opts so that we can unwrap them later. We can say const before is equal to before opt or else. Return. I guess this can fail, which is fine. We fail to find something. And this is the same with after. Okay. And then we just interpolate the A's and B's, I guess, right? So we have like before A and end.a. I guess we're going to have some sort of like interpolate. We're going to have some sort of like start and start val, end val, and t. I guess we can kind of, oh yeah, it's fine, it's fine. So our ratio between these things is something. Start t minus end minus start is like the distance. And we're looking at like t minus start is how far we're in. So we probably want like how far we are in over the total distance. T norm, we'll call this. And then we just, this returns on F32. And this is just like, start val plus end val minus start val times T norm plus start val. Yeah, maybe. That sounds right. Sure. Then we'll call this like interpolate pause, which takes on start pause to end pause to. I guess this is start val and val. We have to be very careful here. We did use vals everywhere here, which is good. Then we're going to take in the start and end as well. And T and return a pause to. And we're just going to say that like return A is equal to interpolate start and start val A, start val, or end val A, T. And B and B. Entertainment window idea, swimming low poly dolphin. Why a low poly dolphin? For Docker? Maybe? No, Docker is a whale. Okay, so then we can just say return a bone whose A is a interpolate pause of before T, after T, before opt, before A, after A, T, and B and B. That like might work. No field A, so this is actually supposed to be X and Y. My bad. My bad, my bad. There's like a non-zero chance this works. Like, if get bone pause bone. Yeah, let's. I mean, let's fucking run it. Holy shit, it compiles. That never happens. Wait. Look at that. Okay, so it runs at, we should be running at like 30 FPS or something. So we're going to say state.t plus equals delta times 30. And then this is 30 times 30. Fuck. Why do you stop? Hold on, I don't understand. State t. Oh no. State t plus equals delta over 30. No. We have to go through 30 frames per second. So we multiply this by 30. Oh, this has to stay at 30 down here. Okay, so the legs are right. I don't understand why the arms are on like an alternate cycle. The arms are moving half as fast as they should. But that's also pretty fucking sick. Like that's pretty fucking sick. Yeah, I don't understand the arms. I don't understand the arms. And I don't know how to debug. Oh, it's so sick though. Okay. Let's try to figure out what the fuck is going on with these arms. So pretty clearly, it would be related to like an individual bone, I would think, right? Do we have our log WASM? Let's start printing. Let's start printing. Okay. So maybe what makes sense is to try to like, we can infer which bones should be the, oh, fuck me. That would do it, huh? That would do it. The fact that the bones aren't in order. Wait, let's think about this. No, because we iterate the whole list. So the bone order shouldn't matter. So the values at 1 and 30 are the same. I mean, it's easy to check if that matters. I don't think it should. But if we do like this and then rebuild, like, do we see different behavior? Oh, we do, huh? Okay. So that explains it. That explains it. It's related to like the ordering there. So we just kind of fuck up our interpolation search. So it was unexpected to me that there are different lengths. But it feels to me like it shouldn't make a difference. Because here we go through every single item in the animation and we say if the timestamp is less than or equal to our timestamp, then we set before. And if it's greater than, oh, we take the first thing that's greater than. I see. So here we need to say, we need another condition here. And it's and after opt, and item t is less than after opt here, right? So here we can kind of fold these together. So it's like, or this. And this is this. This should be after t. There we go. Attempt error. Okay, we'll try again. That didn't fix it, huh? If the item t is greater than t and after op is greater than null or equal null, or item t is greater than t and item t is less than after t. So this should bring us to the closest one after. Oh, this before one is also doing the same shit. Fuck. Okay, so can we just like set this to like negative 99 and this to 99? And then here we can say this is less than t and item t is greater than before t. There we go. Yeah. Yeah. And this now can actually mirror this. This is greater than. Okay. I think that should do it. There we go. Look at that. Look at that. That's pretty fucking sick. That is pretty sick. Okay, so now, let's just make them run back and forth. Let's just make them run back and forth and push the balls off a platform. So maybe we can like make it so that our platform has a like maybe high friction force, so that the balls are likely to stay. Maybe we don't even need to worry about that. Let's just start by adding a platform that he runs back and forth on. Yeah, let's do that. Let's do that. So I guess we render the platform, which we actually already have a platform sitting in here. So we're gonna set his x to be constant and his y, or his y to be constant, I should say, but his x to go across almost the whole thing. Let's render the platform. So here we'll have whatever the fuck our render is. We'll say render line, and we'll say platform A, platform B, canvas width, canvas height, chamber pixels. Okay, so we run again, and now we have a line here. We can put him on the line and just have him run around. What if each ball was the running man? I think that the way the simulation works is not going to work well for that. Because, like, how do I say this? The, like, simulation, the WASM chamber knows about the responsibility of the chamber is to draw the background and to apply physics to balls, but it is the job of the simulation to render the balls. So we don't really have, like, custom ball behavior, unfortunately. Okay. So I guess on each step, we're gonna, like, move the guy. Dude, pause. And I guess he's just gonna have, like, a constant constant position. His y will be constant, and we'll change his x. And his coordinate system is, like, set kind of fucked up. So instead of being relative to, like, a position on him, it's just relative to the world. So his kind of coordinates are assuming that he's at 0, 0. So we'll kind of just say that we'll do, like, dude y offs is an f32, and this is going to be, like, a constant of, like, probably, what do we think, -1 probably, or 0.1 probably. Then we'll have this as dude x offs, and I guess we'll have, like, he needs, like, a direction as well. Moving right as a boolean is equal to true. I guess we'll just only make him move right because I don't want to deal with turning him around. That's going to be hard. So instead, we'll just have him run off the screen to the right and then run back on from the left. Yeah. Yeah. Okay. And so I guess we're just going to have to set this value to something. So this would start at, like, negative 0.34, negative 0.4. And then here we'll say state dot dude x offset plus equals dude speed times delta. And then we have to make a dude speed. So let's see. We're kind of expecting him to move, like, one chunk in, like, 1 second. 1 Mississippi, 1 Mississippi, 1 Mississippi. And let's kind of assume that he's moving, like, 0.2 per second. Approximately. We can adjust it in a minute. But I expect that he is 0.2 wide. 1, 2, 3. Maybe he's, like, maybe a little less. There can probably be, like, at least 6 of them. So maybe it's, like, a 0.15. Okay. And then when we get the bone pause, we're going to take the current offset. And then for the bone that we return, animation bone, we're going to say that his x is offset by dude x offset. Right? And his y positions are going to be offset by the y offset. And then we return ret. Okay. Okay. And we probably want to wrap this. So we want to say if state dude x offs is greater than 0.4, we'll just kind of reset at the beginning. Okay. And then here we need to pass in the state dude x offs. Okay. What's that look like? Might be fucked, might not be. Network error, we have to wait. Wait, that's actually not that bad. That's actually not that bad. We offset him on y the wrong direction. Which is kind of surprising, but whatever. It looks so fucking stupid, man. Oh, man. Okay, so now we just have to add some collision to him. It would be kind of fun if we managed to get each leg to have collision. Like, it would be fun to get him to like kick the ball and stuff. But I think that would mean that we'd have to like calculate the speed of each limb, which I don't want to do right now. And so instead, let's just give him like a collision volume or something. I'm just gonna give him like a rectangle around him because we have 15 minutes left before stream ends, and I don't think I'm gonna get anything more advanced than that working. So let's give him like a force field. It has a PowerPoint transition kind of vibe to it. Yeah, it kind of does, huh? What was I just typing letters into? That's really scary. Sometimes I just start typing like Vim letters into a window and it like does stuff. Like just there, I typed K into the fucking stream manager in Twitch and it paused the VOD. And that's fucking scary, or the stream, I should say. Because it's just like, if it just does actions on that thing, then it's fucked up. Okay, so here I guess we'll make like a function that's like get physics surface. Yeah. And this is gonna take in self and return a surface. And this thing is just gonna be basically like his height. So how tall do we think he is? like maybe 0.3 tall is gonna be my guess. So his bottom is approximately at the platform location. So top y is going to be like 0.3 plus platform dot ay. Doesn't really matter. Then we are going to put the x value at like 0.5 plus dude x offs plus like half his fatness. How fat do we think he is? We said 1.5, so 0.7 ish. Doesn't really matter that much. And then we will return a surface that has A. We need to make sure we get the direction right. So the ground points up if A is on the left of B. So it's going to point to the right if A is on top of B. So this is going to be x is equal to x, y is equal to top y. And then the B of this thing is going to be y is equal to platform AY. Okay. Okay. So now we can say when we calculate our physics that we get like some platform. It's going to be state get physics surface. Okay. We're not going to use platform, we're going to use surface here. Oh, we still need to work on the platform itself. But we also need to work on the surface. So we're going to do another collision check here for each ball. And it's going to look very similar to this. But we're going to look at let's just use the ball center. I don't really give a fuck. Then we're going to look at the ball velocity multiplied by the delta. And then we're going to make sure that it looks to the collision resolver that the ball moved however much the physics surface is also moving. So we need to add like some like left movement. So we're gonna say like ball dude apparent travel is this. But then we have like this is his x value is we're moving to the right, so it needs to look like the ball moved farther to the left. So there's going to be dude speed times delta. Okay, I think that's right. Not sure, but I think so. then we have some resolution. If there's some resolution, we are moving to the right. So where this is going to be vec2. So dude movement is going to be like dude movement speed is equal to a vec2 with x is dude speed and y is 0. So I'm pretty sure that that's what I have to put in here. I'm pretty sure that the other day I added like the speed that we're moving relative to the ball will like push things to the right, essentially. We'll call this var resolution so that I can reuse the same words here without worrying about it. This is going to be physics vec2. And this is unused, surprisingly. So it's because here, this is supposed to be surface collision resolution, not platform. There we go. Okay, there's a chance. It doesn't really feel like it's working. Doesn't really feel right. Okay, so can we render the physics surface? That will probably help. That will help. Okay, so it's when the ball center hits it. Oh, yeah, there's some bugs. There's something wrong in there. We are trying. Maybe this is the wrong way. It's possible. Can we go with like less balls? Interesting. I feel like this should work. Should work. Okay, let's look at this again. So we can compare this to the spinny bar one that we had working the other day or yesterday, or I guess today. And we can just look at like his collision resolution and see how it's different. So he calculates the movement of the ball or of the bar this frame. And then he uses that in the collision resolution. He says, hey, I want to take the ball's velocity and add how much we moved, but in the opposite direction. Oh, and then his collision was higher, probably to push him out. And he also has this push if colliding, which is also probably important. Okay, so let's do surface push or push if colliding ball delta. Okay, that should help. And then let's increase the elasticity of this thing to try to like push it out a little more. Here we used surface collision point velocity, which is correct here. Yeah, and this feels like it should be minus equals. Okay, so this is how much we moved this frame. Let's see if that helps. Let's see if like just the push thing fixes it. Oh, that does feel a lot better. I mean, it's not perfect. Definitely not perfect. But that's pretty fucking fun. That's pretty fun. That is pretty fun. I think. Let's see. Let's unrender that thing so that like at least we can see what it looks like if we are not rendering this. What am I working on? Give me 1 second. I just want to try one more thing and then I'll show you kind of the full thing. You know what? I'll fucking take it. It's far from perfect. But I think that like that's very cool. Okay, so whoever else asked what we're building, we can show you. So we're working on this like collaborative Rube Goldberg machine. So the idea is that like each of these environments is like a WebAssembly module. And the idea is that like once we are ready, we can let anybody just upload a WebAssembly module if they can log in with their Twitch account. And it will be like added to our global simulation. And so The idea is that like because it's WebAssembly modules that just like draw pixels to the screen and apply physics, they can have like incredibly custom behavior. And we're just like right now trying to fiddle with what does it look like to have something that's a little bit more a little bit more custom like this one, right? What does it look like to make an animation of a guy pushing some balls around, right? So that's where we're at right now. I'm happy with this. I want to look at if we try to build this thing in release mode. Optimize release small. I want to see like how big this module is in comparison with other ones. Because like what I want to know is if like compiling an animation like this is like very expensive or not very expensive. So here we have dude coming in at a solid 5.1K, which is actually smaller than the spinning bar. So it looks like this like 5 kilobytes is actually like dominated by like the physics library calculating in like the spinny bar example. Fuck, let's run the code actually. Hold on. So in this like spinning bar, to do like our physics calculations, we have to like basically say, okay, so given from the center to the edge, how fast are we spinning? So there's like a few dot products in there, and then like calculations of pushing the thing out. So it looks like the idea of like compiling in an animation, like a keyframe based animation like we had here, is actually like relatively cheap. Like it's nothing compared to just like physics, which is really good for us. That's really good. That means that we don't have to worry too much about like getting like crazy with like super custom behavior. Yeah, okay, pretty cool. If I may, how is the WASM being generated? I have a transpiler I'm working on in Lua. I've been tinkering with the idea of WASM. WASM is just like, I'm not 100% sure what you're asking, but we are writing our modules. We have examples of modules written in all of Zig, Rust, and C. So we have like, here's a Zig librs that we're compiling to a WASM module. We have these Zig ones that are compiled to WASM modules, the C one. So they're being compiled with like the Zig compiler, the Clang compiler, and Rust compiler. And then we're not using any like bindings generation or anything like that. We just have how do I call it? My brain's melting. We just have like a raw WebAssembly API of like you need to implement like these like 7 functions or whatever, and then you're good to go. Yeah, okay. Well, this is a really fun stream, guys. I had a lot of fun with this one. I honestly thought it was gonna be harder. It's kind of nice that like everything just kind of like worked smoothly. The idea of like drawing out our guy here and then importing him into Blender was really fun. I like the idea that like, we have like this is what we rendered and this is what he looks like. It's not that far off. It's like a little far off, but it's not nearly as bad as I thought it would be. It'd be kind of fun to be able to like get the like hand-drawn look in. I feel like that would be kind of cool. But I think that that's a problem for another day, and I think we made like really, really, really good progress today. Like I'm really amped on this like idea of being able to like generate Zig code from Blender with this. Like it just feels like really cool, really good. So thanks for watching, guys. We're gonna call it there. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. So it's 4 o'clock Pacific time now. 2 hours ago now. I say 2 hours, but that's kind of a lie. We've kind of been doing like 3.5 hours starting at 12:30 Pacific time. But we are calling that like the pre-stream. So the idea is that like the main VOD gets archived to YouTube under playlist, so you can check that out if you want to. There's a lot of stuff in here if you want to check it out. And the idea of the mainstream is like we're trying to make like rapid focused progress, right? But often when we're making focused rapid progress, I call it like prototype mode. We leave a lot of garbage behind. So there's a lot of stuff that has to be done that's like either doesn't fit well into like a YouTube video, it's not like a well-defined feature, and like maybe we have like a bunch of shit left over from the previous day. So we kind of cover stuff like that in the pre-stream. Today we were working on like an admin panel for accepting what is it called? Like staged WASM modules or whatever. But a lot of times it's cleanup. You might see some like Git refactoring, Git stuff, some like refactoring, some minor improvements, stuff like that. So if you want to check that out, you can swing by on Twitch, or they're archived on Patreon. There's a GitHub link in the Twitch description where you can see code for all of this stuff. So that's around. Otherwise, I think we will call it there, and we're going to say goodbye to YouTube and Twitch. Let's find someone to raid.